Okay, so we're going to talk a little bit about this titration curve lab and how to finish this. I think hopefully most of this stuff you understand now, especially after the notes from the other day on molarity and titrations and all that stuff. So titration, basically we're adding a little bit of a known concentration of either acid or base to an unknown acid or base. And it actually doesn't have to be an acid or base. That's the typical titration that we do, but there are lots of other different types of titrations that can be done. I think one that we talked about on the notes was a titration of tap water with silver ions, because that would precipitate out silver chloride and you could tell the concentration of the Cl- that's in there. So there are a lot of different reasons to do a titration, but essentially what you're trying to figure out there is how much of something there is in the solution, okay, of an unknown. So we already did the titration. I think you guys are pretty good as far as how this actually works here and why we're doing it. Should have gotten your data here, and when you're doing your graph, a lot of room here to draw this, but let me just kind of show it to you here. When you actually graph this, and you should have, let's see, you should have the volume of your base down here, volume of base added, and then you should have your pH over here, okay? And so you're going to start out low on the pH because we're starting with an unknown acid. We don't know exactly what it is, but it's an acid. And it's going to go up slowly, slowly, slowly at first until we hit close to that equivalence point, and then this thing is really going to spike. And then it's going to level off again. Right there in the middle somewhere is going to be your equivalence point, okay? And so that's approximately what your graph should look like. Don't try to draw a best fit line through all these points. You don't want a straight line on this one. That wouldn't work very well. So that's how that's going to look, okay? Let's see here. So then once you've gotten that, it says from the graph, find the volume of the base required to reach the end point, okay? Now it says end point here. That's bad terminology, okay? We want to figure out the equivalence point from the graph. So you might just change that on your lab. But basically you're going to do what I just, what I just told you. You're going to find that point on the graph that's right in the middle of that jump, okay? And that's going to be approximately your equivalence point. So this is not going to be perfect, but hopefully it'll be close. And then what we want to do is find the moles of the base, okay? So in other words, we need to find out how much of the base that we had to add there, okay? Now we know that the concentration of our base was 0.1 molar in AOH, okay? And we also know that the volume of base added was whatever, okay? So that's why they had you do number 1 here, okay? Find the volume of base required to reach the equivalence point. So once you find this, let's say it's just hypothetically, 25 milliliters or something like that. You had to add 25 milliliters of the base to get to the equivalence point, okay? And again, the equivalence point is the point at which your volume of your moles of your base is equal to the moles of the acid that you had originally in the solution. So it's completely neutralized. With a strong acid and a strong base, your equivalence point should be at a pH of 7. I guess I should have said that also. So you're not just looking for that point that's in the middle of that spike. You're looking for when the pH is equal to 7, okay? Because that is, for a strong acid, strong base titration, that is when you're going to have the equivalence point, okay? So, and it's kind of telling you what to do here. It's saying volume of base in liters times the concentration of the base is equal to moles, okay? So we know our molarity equation here. Molarity equals moles over liters, okay? We know the molarity of our base. We know, hypothetically we had to add 25 milliliters, so that's 0.025 liters. And we just need to find our number of moles. So you take the bottom here, the 0.025 liters times 0.1, that's going to give you your number of moles, okay? Write and balance the equation for the reaction of HCl with NaOH. I think you guys can do that. Just go ahead and leave this as the molecular equation. Okay, for now. We all know, I hope we know, the net ionic equation. For this one, it's just H plus plus OH minus gives you H2O. But we don't need to necessarily write it that way here. Actually, I think it'll work better for you for your calculations if you just use the molecular equation, okay? So just write it like a double replacement, and you can go from there. There's not a lot of balancing to do on this one. The moles of acid required to react with the calculated moles of NaOH. Okay, now that you have a balanced chemical equation and you know the moles of NaOH that you have, because you calculated that up in number 2, then you should be able to figure out the moles of the HCl, just using the stoichiometry in the equation, okay? And actually, if you know, this equation is not hard to write. The stoichiometry is going to be 1-to-1, okay? Then you can determine the concentration of acid in moles per liter, okay? Now, what I want you to do is essentially, I want you to determine the concentration of the solution after you diluted it, okay? And so I think they had you start with 10 milliliters. Let me come back up here and look. So they had you start with, I guess it's up here. No, it's not. Let me find it. Oh, here we go. Okay. 10 milliliters of unknown HCl, and then you're diluting it with 75 milliliters, okay, of distilled water. So our total volume of the HCl solution there is 85 milliliters, okay? Come back up here. So 85 milliliters. That would be your volume of your acid, okay? So you know from up here, you know the moles of your acid, and you just want to divide that by the liters, okay? Which you got 85 milliliters, so you just need to change that to liters here. Plug that in at the bottom of the equation, and that will give you your concentration, okay? And that'll be the concentration of the solution that you made after you added the 75 milliliters to it. If you want to go back, if you're curious, you want to go back and figure out what the original concentration was, then you can do an M1 V1 equals M2 V2, but you do not have to do that, okay? Repeat for all trials, well, we only had one, so you really don't even have to worry about number 6, okay? And then it's just asking how would the following affect the results. The burette is dirty and drops of NaOH cling to the side walls of the burette as it is drained. Burette is not rinsed with NaOH prior to filling. Burette tip is not filled at the start of the titration. Okay, I'm going to give you some starting hints on these, but I want you to kind of think these through and just think through the calculations that we did and how it would affect each of these, okay? So if the burette is dirty and drops of NaOH cling to the sidewalls of the burette as it is drained, that is going to affect your your volume of NaOH. So the volume of NaOH here, if this happens, we would actually report it as greater than the actual, okay? So in other words, what we are actually adding to the acid is not as much as we think we did, because we're going from 0 down to 50, or from, 0 down to 50. So once we think we've added 50, we've maybe only added 49 milliliters, okay? So that's the effect that would have there, so then you got to think about how that would affect your calculations. The burette is not rinsed with NaOH prior to filling, okay? That, let's say that we've got some water in there, okay? Maybe just a little bit of water in the burette and we didn't rinse it with the NaOH first. That might make, again, this is not the answer to the question, these are just your hints on these. Okay, it could make the NaOH less concentrated, okay? Because if there's some water in there, then when we add the NaOH, we're essentially diluting it a little bit. with the water. So that's why you need to rinse it with the NaOH first. Burette tip is not filled at the start of the titration. Okay, so if we don't have the tip filled, then once again, we're not really adding 50 milliliters when we think that we are. We're adding less than 50. Okay, so here, I should put this up here. Recorded volume of NaOH is going to be greater than the actual. That's going to be the same. We're going to have the same situation here on C. Okay, but we think we added. If we think we added 50 milliliters, really we're only adding 48, 49, something like that. 20 milliliters of the unknown acid are used instead of 10 milliliters. Well, that's going to increase the concentration of the acid. This is an abbreviation for concentration, by the way. That's not really going to affect a lot, other than your final concentration of acid is going to be, it's going to be higher, which means you're going to have to add quite a bit more of the NaOH, which means you might have to refill your burette, which could be a problem. Burette is not read at eye level. Okay, well, that depends on, depends on, are we above it or below it? And then I'll let you guys think about what that would do. I mean, most likely you're going to be below it because it's up so high. But you guys can think about how that would affect it. Burette is added or the base is added too rapidly in the region of rapid pH change. Okay, so then, and then some of you actually did this, so your data is not that great in that range. So then you've got to think about what's going to happen if you added it too quickly. 100 milliliters of distilled water is used instead of 75 to dilute. Okay, well, this is this is the opposite of D. Okay, so D from above. It's going to be the opposite of that. The acid will be less concentrated. And the original volume of base is not at 0.00, and a student assumes that it is. Okay, well, again, depends on which direction it's off. Okay. Alright, so there's your hints on those, but I want you to actually think about what these would do, okay? And I know these are a little bit tricky, but try and do those, and you can come ask me if you have any questions if you're just really not figuring one out. But this is the kind of thinking they want you doing on the AP exam for the lab portion, so I really want you guys to be able to do this sort of thinking when you get to the end of a lab, okay? Alright, so that's it for the titration curve lab. Hopefully that makes sense. And we'll see you guys in class.